Oh, okay, hold on. Yes, hi. I'm gonna do an Advent of Code. Ooh, yeah, let me pause that. I'm gonna do an Advent of Code challenge. It's like a coding challenge in Rust, and I'm pretty new to Rust, so I'm trying to practice it using these. I've been like interested in Rust for a while, but haven't really done too much with it yet. So the confession is I actually already sort of started this one. I was like, oh wait, no, let me make a screen recording of it. That'll be interesting. So I'm starting over. I didn't get very far before I had that thought, so don't worry too much. The idea is that we have um, a few things here. We have this concept that there can be a kiosk with all this data on it, and it's random for each person who's doing the Advent of Code. This is what my data looks like. And each of these lines represents a room, and some of them are real rooms, and some of them are decoys. And actually, I haven't read too closely the part about how you define what is real and what's a decoy. So I really haven't gotten that far. And we have this example, and so we need to take in our list of rooms, figure out which ones are real, and then add up this number component of the room name, and that's called a sector ID. So the pattern here is encrypted name. So that's this first part, and or sorry, this first part up to the number, I guess. Then a sector ID, and then a checksum. And a room is real, not a decoy, if the checksum is the five most common characters or letters in the encrypted name in order, with ties broken by alphabetization. And um, yeah, so our goal is to read in all the lists, filter out the decoys, add up the sector IDs. And so my general strategy with these is to use the example that they give and make a test case that um, asserts that the test case has the correct value, and then and then uh, try it for the input and see if the number that it produces is correct, and you can submit a number to, and the system will tell you if you got it right. So let's get started. So I have this folder called Advent of Code 2016. It's a Git repo. I have one subfolder for each day. I'm going to use Cargo to make another one, and just check in on Git status. And um, I'm going to add a Git ignore. It's just stuff that I have gotten the habit of doing for the first 3 days. Uh, okay, so this is our project. We can do cargo run. It'll just print out hello world because that's the default thing. And yeah, so let's start setting up that test case that I was talking about. So we can write a test, and the way we do that is we write a function that I'm just calling example. And in order to write a test, we kind of need to start thinking about what our interface is going to be for this. And so I think I'm going to say something like, there's this idea that there's this kiosk with a list of names, an information kiosk. So I'm going to say something like let kiosk equals kiosk new, and then string from example.txt, and I'm going to say let or assert kiosk dot sector ID sums, or I guess assert equal. So we're going to assert that the sums is equal to 1514. Okay. And there's no way this will work because we haven't defined any of this, but we can try running it with cargo test, and we're going to start getting compiler errors, and that's going to be, I think, a way to test drive this out. And cool, so I'm going to add a file called kiosk .rs and open that down here. We're going to need to say mod kiosk to pull in the file, and then use kiosk : kiosk to pull in like In the Ruby world, I'd call it a constant. I guess here you say struct, say pub struct kiosk. And so if we run the cargo test, we're getting an error, and this error tells me that we don't have a new method yet. So it's not like Ruby. You don't have like a constructor method concept. I'm gathering that the convention is that you write your own. So just the reason I did pub here is that otherwise I would say that you can't like use it because it's private. So everything's private by default. So you say pub and then it can be used. So the thing with Rust also that's different from Ruby is there's not like one block that has all of the information for a class, and structs are kind of like classes. There's the first block where you say pub struct that has all of the like attributes and data, and I haven't defined any yet, but I think we probably will have some. And then there's a second block called impl for implementation that has all the methods or functions. So I'm going to say function new is going to return a kiosk, and for now I'm just going to return like an empty kiosk basically. So let's see what we get. Try to run this again. We're getting an error because so one thing I really like about the Rust compiler is that like there's actually a lot of errors. I made a lot of mistakes there, and it's clever enough to tell me what all of them are instead of just like the first one, right? So first error is that I misspelled kiosk as kiosk. I can fix that. Second error is that this new function that I defined isn't public. Everything's private by default, so I need to make it public in order to call it from outside the file. Thirdly, I didn't define the new function to take in a file name parameter, so that's not right. And thirdly, there's no instance method called sector ID sum. So like those are all the problems. And like I'm gonna close this little error window, and I probably won't remember all of those problems, but I will remember a few of them. So fix that typo. So kiosk. Then I'm gonna say it takes in a file name that is a string. I guess I'll call that file name. And then I'm going to do an instance method. And to do instance methods, you have the first argument be a reference to self. I'll have it return a unsigned 32-bit integer. And I'm just going to put in 4,000, which is not the right number. Yeah, that's also private. So, oh, right, this one needs to be public too. Okay, cool. So now we did compile, but the test fails because we got 4,000, but we expected 1514. So that's pretty good. So now we can actually start like implementing this stuff, and we can add more tests as we go if that feels appropriate. So one thing that is obviously wrong is that we're taking a file name, but we're just not doing anything with it. The syntax for reading files I am yet to remember, so I'm going to reference day 3. They pretty much all have reading in files. So first of all, you need to bring in some stuff from the standard library, I guess you'd call it. And then this is how I've been reading stuff in. So the first thing you do is you make a file, you make a file object by opening the file name, and opening a file can fail. For example, if the file doesn't exist. So we use unwrap, which is to say, like file open is going to return a result type, which means either a successful opening of a file or an error object that explains why it didn't fit, why it wasn't successful. And in theory, we should handle both of those explicitly, and like have two code paths. One that follows the here's the happy path where we were able to open the file and we're going to continue and do it. And here's the sad path where we couldn't open the file, and what should we do in that case? And for these things, I'm just saying unwrap, which is to say, if you couldn't open the file, just panic. So panics are kind of like runtime errors, where you can just say like, just stop. Like that can't be right, and I don't want to deal with it. And cool. So we make a mutable variable binding that opens the file, and I'm not sure why it needs to be mutable. I guess I don't know that we're mutating the file, but apparently we are. And then make a mutable string, and then read the file to the string. and then that can also fail, so we just unwrap that because we also don't care about that. So I'm going to print out uh, the string here just to see, like, I just want to confirm that that we can read the file, and in fact we can't because we get this error message. So this is what the runtime error thing looks like. Thread example panicked at a called result unwrap on an error, and the error was no such file or directory. So that makes sense because we're passing in example.txt, which just doesn't exist. So let's make example.txt, and I'll put the contents of this in it. And I gotta manipulate a little because it's kind of awkward. Nice, okay, so I think that looks right. So let's try running cargo test again. Nice, okay, so we're back to this error of, or this test failure of expected 1514 but got 4000. All right, so now we're reading the file from the file name, but we're still just printing it. We're not actually doing anything. So what do we actually want to do with it? I think we want to do something like for line in s.lines. So each line represents a room, right? So we can maybe do something like let room equals room new from the line, and then what? Well, we're going to need the kiosk to be able to hold on to the rooms, right? So let's say like a kiosk is something that has an attribute called rooms, which is going to be like a vector of rooms, and so rooms don't exist yet. So we're definitely going to get some errors there. And then, yeah, so let's say let rooms equals, or let's mute, this will have to be mutable because we're going to, what I want to do is make like an empty vector. So we'll say this is a vector of rooms, and we're initializing it. The reason I'm specifying the type here is just so that this is able to know, like, this is like the general way to make an empty vector. Ooh, wait, no, we can be more clever. Okay, well, to finish that thought, let mutable rooms is going to be a vector of type rooms, or a vector of rooms, and then we're initializing it as an empty one. And what I was thinking we would do is something like rooms.push room, and then we'll say rooms, right? So we're going to do this, and let's actually make this work. So use of undeclared type or module room, rooms undefined, that's right. I'm just going to make a note to self of what I was thinking for like the more clever version. Use map collect. Maybe we'll come back to this. Maybe it doesn't matter. The stakes are low here. So let's just follow our error messages. So the problem is that we're referencing room, but room doesn't exist. So let's bring it in. Let's say use room. Let's make a file called room. Let's define pub struct room. And I think we're missing a step. We are, so we are trying to use room, but there's no modular crate called room, and so I think, I'm not sure, like it feels kind of, I feel like I should be able to say mod room here, but I don't think it's going to work. Yeah, exactly. It's saying cannot declare a new module at this location. So I happen to have learned from trial and error that you have to declare the module in the main file, and then you can use it wherever you want. Cool. All right. So now it is finding the struct, but it's complaining there's no new method. That makes sense. So let's give it one. Let's say impl room. So we're going to start. This is where we start adding the methods. Pub fn new. And let's say raw description. What do we want to call this line in the file? It'll be a string, and we'll return a room. Let's just return a vanilla room, just to get to our next error. Okay, so now we're into weird type stuff. So we expected a string because that's what I declared my type, my function signature, but we actually got a reference to a string. So this is where I'm not very confident in my Rust abilities, and I think what I'd like to do here is just say to owned, which is gonna like coerce it to be the type I expect. Uh, and I just don't know if that's actually the good thing to do, but it's a thing that I think works. Um, cool. So now we're back to this familiar test failure of expected 1514, got 4,000. And we're still sort of driving it out. And so in order to get, in order to wonder or check like how we're doing, I want to add one more thing here, which is like, I want to do debug printing of the kiosk. I just want to see what the kiosk looks like to verify that um, it has stuff in it that looks right, and I think it won't. Right? We're gonna get it printed out. We won't get it printed out. So we're using this colon question mark syntax, which is supposed to print out the object. And Rust is like, I don't know what that should look like. How am I supposed to print out your random struct that you invented? We're able to help it figure that out by telling it to derive debug, which basically just means like, hey, when you print this object, just like don't worry about it too much. Just like print out the name of the object and the attributes and the values of those attributes, and it doesn't need to be pretty. It's just for debugging, and that's fine. So we try again. All right, so now it's saying the same thing for room. So because a kiosk has rooms in it, then we also need room to be debuggable. So we'll derive debug here as well. And I think this should print now. And what we're going to see, where is it? It might be that like the test runner suppresses some output. I'm not actually sure. Oh, no. Here we go. Nice. So this is the output. It's just the example standard output. So I think they do kind of control how the output shows up, but nice. So it looks like we have a kiosk with 4 rooms, and they don't have any data. So that sounds right, because we pass in the data from the line, but we don't even really do anything with it, so it makes sense that there's no data there, and we still have the same test failure. It's also helpfully telling us, like, hey, you passed in this raw description, and you're doing nothing with it. That's an unused variable, so, like, we'll compile, but we're going to print this warning, so there's a way to like disable the warning, but it's actually really helpful because it's telling us that we're not done yet and kind of telling us what to do next. Cool. So now we need a way to parse the raw description. So to review, a room is real, not a decoy. If the checksum is the 5 most common letters in the encrypted name in order with times broken by alphabetization. So a room is going to have an encrypted name, a sector ID, and a checksum. And the checksum is just a thing in the square brackets. So I think that that's a good clue. I think we should define that. These are the types, or the attributes on this type. And I'm going to say encrypted name is a string, and then sector ID is a string, or I guess sector ID can be a U32. Oh, God. U32. And I'm assuming they're all positive. Maybe that's something I shouldn't assume. Yeah, they must be, because the dash is used to separate it. So how would you communicate that if there's 2 dashes? That's the thing. I haven't looked at the big input file, just the little one. I'm not going to worry about it yet. Sector ID U32, and then checksum is going to be another string. Okay. Nice. So now here we have to parse out those values. And I'm trying to decide now, like, do I want to use like a regex for this, or what? And I think I do. It might be a clumsy tool. I just enjoy regular expressions. I think I'm going to. I'm not sure if it's wise, but I just think that's what I'm going to do. There's a nice package called regex in the crates package manager, which I think is made by the Rust core team, but it's not part of the standard stuff anyway. Let me go to the homepage. Yeah, so it's like part of the Rustlang nursery. Ooh, that was interesting. When I hovered, it just says it's Rustlang/regex. When I clicked through, it got redirected to Rustlang nursery. Um, okay, yeah. So let's try adding a dependency. So interestingly, regular expressions aren't built into Rust, but they are available. So this is how you can use them. Da, 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 da. So external create regex and use regex. How did that? Ooh, that's strange that they are using semicolons here. Do I have to use semicolons? Oh, I do. No, it's not strange. It's normal. Woof. Okay, that makes sense. Sorry, excuse me. I just had a weird lapse where I thought you didn't need. Anyway. Cool. So now we have the ability to make a regex. So I'm going to say regex equals regex new, and I'll put the pattern there. And then I think I'm going to. Oh right, we can define it using this other syntax, which I'll talk about in a sec. And then we're going to unwrap the regex. So I think that's like an assertion that that the syntax is valid for the pattern. So if you tried to make a regular expression that didn't have valid syntax, you would get back a result type with an error. And if you have a valid syntax, I think you'll get a result type with a pattern that you can then unwrap. And for our purposes, I'm just going to unwrap it every time and just assume that the syntax is right. And if not, I'll fix it and it'll be fine. Okay, cool. So if we look at our example, this is what it looks like. So we need to define a pattern that matches these. So I think I'm going to say, it seems like everything is lowercase so far. So I'm going to say A to Z and hyphens repeating. And I'm going to say it's the beginning of the line, and then A to Z and hyphens repeating. And that's going to be the first match group. And then a hyphen, and that'll be the second match group. No, that'll be in between the match groups. Then what looks to always be 3 digits, but I don't want to assume, so I'll say digits repeating. And then that'll be the second match group because it's in parentheses. Then open square bracket, open parentheses for this third match group, A to Z repeating, and close third match group, close, opens, close square bracket, end of line. So I think that might be legit. And how do we actually use our regex? I'm going to try cargo test now just to see if that compiles. I'm curious. What this is doing now is it's actually downloading the regex crate and compiling it. So this build is taking a little longer. And then it should run it, and we'll see if everything compiled and if the regex was any good. Oh, okay, so a few interesting errors. I guess one thing that I was surprised to learn through this exercise is that if you want to import an external crate in a module, you need to prefix it with self : that's interesting. So what was the next error? The next one is that I forgot to say let. And the other thing was that I tried to make a room without any types, and now that we have types, we need them. So I'm going to say encrypted name slime. Sector ID 4000 and checksum slime. So that's just a term I learned from Gary Bernhardt videos where he will add input that actually I'm not using it the way he uses it, but like I'm putting something into The way he used it is kind of different, actually. I'm not going to worry about it. I'm just putting it so it'll compile. That's all that really matters right now. But of course, it won't compile because in order to make an object of type string, I can't just use quotes because that makes a reference to a string. So to make an actual string, capital S string, we use this syntax. Cool. So now we're compiling, and oh no, we're not compiling because I have an unrecognized escape. That's interesting. So at position 7, it says position 7 surround kind unrecognized escape. Let's look for position 7 in here. 1, 2, 3, 4, 5, 6, 7. All right. Well, it looks like I don't need to escape my dash. That's interesting. I would have thought I did. Let's try again. So now I have the same thing at position 11. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh yeah, same kind of deal. Guessing there'll be more of those. Ooh, no, okay, cool. So we're back to our error. So like I'm starting to get to the point where I probably should be writing more tests, right? Because I've got this regex and I'm not really testing it directly. So now I'm going to add some more tests in this crate that are testing the room new method directly. So I'll say fn. There's this interesting syntactic thing. Like these look like comments, and I'm used to hashtag meaning comment in Ruby and CoffeeScript and Bash. But in Rust, comments are like this. And this is something else. And I don't know the term for it, but I feel like I've heard some terms, but I forget what they're called. But the idea is that this is somehow annotating the function, saying this function is a test. And you don't put it in a separate file. You can put it right here. There might be a way to put it in a separate file. I wouldn't be shocked, but you don't have to. And I kind of like putting it right here. So let's try. So let's say, yeah, I'm just going to call this new. And yeah, so let's say let room equals room new. And I'll just borrow the first example from our examples. And I'll say assert equal room dot encrypted name, and that should be the first part of this. Oh, shoot. Too many quotes on the dance floor. Too many quotes. And we're going to assert that the sector ID is 123. And we'll assert that the checksum is ABXYZ. Nice. With another quote. So if we try cargo test now, it doesn't compile because I needed to string new. This is something that takes some getting used to. And now room new, expected 0 parameters. Not string new, sorry. String from. Yeah, even more getting used to than I let on. And all right, so both fail, which makes sense. So the room new test fails because it's getting slime, and it's supposed to get A. So now we can try to make that one pass. And yeah, so I gotta remember the method, or look up the method again. Right, so do captures, nice. So let's say let captures equals regex dot captures raw description. And yes. And encrypted rooms from slime. Dot unwrap. So again, if anything goes wrong, I don't really care right now. And so instead of slime, now we want captures. Ooh, they're using named captured groups. That's good. I'm just going to use numeric capture groups. I think that's simpler for our purposes. So I'll say captures at position 1, captures at position 2, and I'm going to need to coerce that to a number at some point. Captures at position 3. So maybe for now, actually, I'll just let that be a string as well, and to do make this number. I'm sure it'll come up organically, actually, forget it. So let's let this just be a string for now for simplicity, because we don't need it to be a number yet, so there's no reason. And I think for each capture we may need to unwrap as well, because there's always a possibility that there isn't anything at that position, I guess, is the reason. Okay, so nice. So we're providing references to strings, and so I'm gonna I'm gonna do this to owned thing again. Feels wrong, or it feels verbose and weird, but I'm just going with it for now. Nice. Okay, so we were passing in the string to the captures method, and that should be a reference. So that's easy enough to make a reference. And so it looks like we have one passed and one failed. So that's awesome. It looks like our this test down here is passing. So now that that one's passing, maybe it's a good time to make this a number again. Just incremental progress, you know. So if we change that, then this is going to fail because it's like, hey, I expected an unsigned 32-bit integer and I got a string. So how do we do this? I think we do something like this. So we have, at this point, we have the reference to the string. So let's say now parse into a U32. I think that's a way to do that. It is not a way to do that. Okay, so after we parse, we unwrap again, because what if the parse failed? In theory, we should handle that. Nice, so back to one passed, one failed. So that's good. Cool. So I feel good about that. I'm going to close that for a sec. Let's go back to our kiosk. So our kiosk is the thing that's returning our slimy 4000 number. What we really want this to do is return the sector ID sums of the actual non-decoy rooms. So we're going to need a way to figure out which rooms are decoys and which aren't. So in order to do that, we're going to need to know whether a room is a decoy or not. So I think that's probably the next thing to focus on, is adding like a check for whether a room is a decoy. So let's try writing that. Let's say test fn, hold on, test fn decoy, and let's do the same one and say assert, and I'm going to go back to here to see this is a real room, and I'm not going to worry yet about why it's a real room. Let's actually just call this real to be positive. So assert room.real, yeah? And then this next one should also be real, right? So we can say let room2 equals room new string from this guy, and we want to assert that room2 is real. And then this next one is also real. Okay. Let room3 equals room new string from, and assert room3 real. Let room4, maybe this should be separate tests. I'm not worried too much. Equals room new string from, and we're going to say assert not room4 real. And so our expected failure here is probably that, well, it's either going to be that there's one of these unwraps is going to fail because we only tested that with one input so far. Another possibility is that Well, I think the failure we expect is that the real method is not defined. So yeah, that's what we're seeing here. So no method named real. So that's easy enough to add. So fn real, and it's going to return a bool, and I'm just going to say true. And let's run it. Ooh, interesting. No method named real found for type room. That's right, because this should be an instance method. Let's try that again. All right, so we have an assertion failed, room 4 not real. That is pretty much what we expected, right? Because it just returns true, and rooms 1, 2, 3 are real, and room 4 is not real. So now we need to actually define the realness. This is good, so let's reread this. A room is real, not a decoy. I'm just going to paste this here for a sec. A room is real, not a decoy, if the checksum is the 5 most common letters in the encrypted room in order with ties broken by alphabetization. Okay, this is where it gets annoying and mathy. So far I've just been like organizing files, but now we've got to do mathy stuff. We got to add some numbers together. I don't like this. All right, cool. So if the checksum is the 5 most common letters in the encrypted name in order, so the way that I think I want to do this is something like calculated. Hold on. Self.calculated checksum equal self.checksum. Right? Like, I think what I want to do is calculate the checksum based on the encrypted name and then compare it to the provided checksum. And if they're equal, then the checksum is valid and the room is real. And if they're not equal, then and it's not real. So this is sort of a tactic to stall on actually doing the hard part of like the mathy stuff, and to get to another failure that I can easily understand, which is that, hey, this method doesn't exist. So let's just kick that can very slightly down the road, and shoot, we're back to here. So now we've got our slime again, and so which failure do we have now? We have several failures. Example, standard out. Right, so the first room should be real, but it's not because this is kind of bogus. So, yeah, the checksum is the 5 most common letters in the encrypted name, so it should be 5 most common letters in the encrypted name in order with ties broken by alphabetization. I'm going to get rid of this comment. So how do we do that? We have the encrypted name, right? So we can figure out what are the 5 most common letters in it. And it shouldn't be that hard. In Ruby, I would just like make a hash that grows over time that counts the frequency of each letter's usage. I don't know how to do that in Rust. Let me think. Yeah, I mean, we can sort of approximate it in a way like, it's like we can say like for C in self.encrypted name dot chars, so this will be each character. We do something like maybe I should actually just look up like Rust key value pair. Like there must be some data structure here that I'm just not familiar with that we can learn about in this moment. Okay. A hash map implementation which uses linear probing with Robinhood bucket stealing. Yeah, I mean, that's cool. That might mean something. I'm not certain that it does. Okay, nice. Okay, okay. Let's try to use this. I mean, this is definitely an appropriate thing to use, right? So let's bring it in. So we'll say use standard collections hash map. Never used this before. It seems probably like the right thing. So let's say let mutably um, character counts equals hash map new. And I've added this cool Vim integration called Racer, so I should be able to do this and just jump to, it was GD, and jump to the definition of hash map. I'm going to go back though, because this doesn't mean that much to me. Just showing off a cool thing I learned. Cool, so now for each character, I think we want to check if, so if character counts contains key C, or type inference lets us omit an explicit type signature, which would be, okay. So cool. So hopefully we will be able to just have the types be inferred. We'll see. So if it contains the key C, um, else, so if it contains the key increment count, else set to 1. This feels pretty straightforward. So we'll say we can check contains key, we can insert, and we can remove. Can we update? That's a question. Insert a key only if it doesn't already exist. Hey, this seems good. Oh wait, so it gets or inserts. Interesting. Okay. So down here is like all the methods that exist. Hasher, yeah, I don't know what that means. Keys, that's nice. Values, sure. All right, so I learned you can click this minus sign to kind of collapse everything, and you can. It's kind of like zooming out and seeing all the methods that exist, and then this description is probably still where I want to be. Okay, so well, this one is more straightforward, right? So we can say character counts, insert C1, right? I think that's straightforward. And here, so we've already, okay. Da, 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 da. We can get the length, we can try to get at a key and then unwrap it. So we can do let current count equals character counts get character unwrap, and then we can do character counts remove, and then character counts insert. I mean, this feels wildly like there probably is a method that does that better. So what I want to do now is I want to see, like, all right, first of all, does this compile? Second of all, what does this thing actually look like? So I'm going to do this debugging printing thing again, and let's try to run this. So expected reference found care. So we can always, I guess, always pass a reference for the key. Got to update a few things. Did I get all of them? So, oh boy. Oh boy. Oh boy. All right, we're getting some gnarly shit here. Cannot borrow. It's also borrowed. All right, so I could try to figure out what all that means, but I felt weird enough about this implementation that I'm now inclined to maybe comment this out. Okay, canon for type. So maybe I should. Oh, maybe I should explicitly set the type here, uh, for the sake of um, I don't know, having more control over the situation. So I want this to be a hash map. I want it to have a character on the left and a U32 on the right. Yeah, can I do that? I can do that. Nice. Uh, so then for character in self-encrypted name dot characters, I don't think that would be enough to make this compilable, right? Well, actually, we're getting a little closer, I think. Um, so let me undo these changes. So we're actually using a character as the key. And now it expects a reference to a character? What the hell? I thought a second ago it said it didn't. Let's undo. Okay, so maybe just when we insert, it must be a character. That's interesting. But now we get these crazy errors. Okay, back to commenting stuff out and rethinking. Um, all right, so yeah, yeah, yeah. Hmm, hmm. So, hmm. So can I understand what's happening? I'm not sure I can. So we want to have a hash map. We want to have characters on the left and numbers on the right. We want them to increment over time. Um, but they can't be references to characters somewhere else because we're just looping through. I think the problem is that we're looping through the characters, and so the C variable. We pass in a reference to the C variable. It that just doesn't make sense because we're looping and C is changing. So like it's a reference to something that is then discarded and replaced. So we don't want to pass a reference. Um, so maybe that's the issue. Shoot. Here we're passing a reference, but that's okay because we're just doing it for the space of just asking a question. Do you contain the key? Uh, and then same with get. We're just asking a question. Can I get the value at that key? Same with remove. For insert, mm, hmm, hmm we just can't insert the value because we're going to loop through and the value will be kind of killed, and we can't pass a reference for the same-ish reason because it needs to persist in the hash map. So, um, hmm. but then how does anything work? All right, so they're getting, they're removing with the reference to a string, contains key with a reference to a string. I liked it a lot. It's like weird. Whew. Okay, we're getting into some gnarly shit here. I'm losing momentum. Let current count equals yes, 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 yes. So one other thought here is um, so if I pull up the Rust docs for the char primitive type, I wonder. It's like maybe I should just be using strings all the time. Um, like this is sort of a desperate thought, but I'm wondering if I should coerce the character to a string or something like that. Um, I don't actually know how to do that. Da, 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 da. 'Cause, 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 Maybe I shouldn't use a hash map. Is there like an alternate approach I could be taking here? Hash map feels good. Um, yeah, I should be using hash map. I feel like I should be using hash map. The character count scale C. Whew. If C in self-encrypted name.char, the character count contains the character, then we want to get it, remove it, increment it. There might have been. I can just read through these examples a little bit more, and that might help like see the patterns of how to actually use this thing. Ah, that's interesting. The easiest way to use hash map with a custom type as a key is to derive eq and hash. We must derive partial eq. Insert a key using a function of replacing value only if it doesn't already exist. Updating a key, regarding as the key possibly not being set. The star syntax I don't really know. This does seem actually like what I want though for this scenario, but I do feel a little nervous that I don't know what the star means that much. Let's try using it anyway. So we're saying let count equals character counts, entry C, or insert 0, and then we say count plus equal 1. All right, that looks good. I mean, that looks way better. And if it compiles, that'd be even better, but I feel like it'll have the same issue. Oh my god, it compiles. Holy moly. Nice. And we can even... reading the docs helps. And we can even see the output here to see, does this look right? Okay, cool. So it interestingly, it's including hyphen, which we didn't really want. So we probably need a way to filter that out. Yeah, so nice. All right, so I'm not quite sure how we like just had a bit of a breakthrough, and it just came from reading the docs, which is nice. Okay, cool. So I'm just going to add a simple thing. I'm just going to say if C not equal hyphen, then we'll do that. And let's try running cargo test to just confirm that the output looks more correct. So there's 1y, 5 a's, 3 b's, 1 x, 1 z. All right. Cool. And so now our checksum is going to be what? We now have a hash map. What can you do with a hash map? We're going to need a way to sort it by the value and then break ties with alphabetization. So is there like fn sort? There isn't. Is there fn iter? There is. So we can make an iterator out of this. And if we can make an iterator, then we should be able to sort it. So I'm going to say character counts dot iter, and then we'll have an iterator. So let's open up the Rust iterator docs. And is there an fn sort? Oh, there's not. Shoot. Okay. I thought there was. Maybe arrays can be sorted. Interesting. Well, okay, so we can go from a hash map into an iter, and then from an iter, we can collect that into an array, and then an array can be sorted. That feels weird. That can't be right. Oh, wait, no. We can collect it into a vec, and then the vec can be sorted, probably. Let's see that. So we can have vec. Oh, I guess we go to vec. Yeah, here we go. So, and we can do a sort by, so we can implement our own sorter. So I think that's what we have to do. I think we have to go all the way from, so like let's say like let sorted, and it'll be or no, not let's sort. Let's say let character count. This is a bad name. I'm just going to character counts vec, and it's going to be a vec of. I think it's going to be a vec of character U32 tuples. Tuples. I'm getting fancy. So we want to collect this into that, and then we'll see if that worked. And I doubt it did. It didn't. Did you mean character counts vec? Oh, indeed I did, but I saw that there was another error too. Okay, cool. So we tried to collect it into that, but instead, collection type char32 cannot be built from iterator over elements of type ampersand char ampersand e32. Well, we're close then, at least. Interesting. Okay, I don't know if I'm familiar with this error. So I think the problem is that we have references, and we said explicitly that we didn't want references. But maybe references are okay. You know, maybe I can be okay with that. Hey, okay, cool, nice. Nice. So, so now this is our vec that has these tuples of those key value pairs, and I think the tuples we're going to be able to sort, and actually, let's say this is going to need to be mutable, because now we want to say character counts, sort by, and this is going to be A, B, where A is one of the tuples and B is another tuple, and yeah, so we want to be able to say, first of all, we want to sort like A dot 0 compared to B dot 0. But this doesn't account for alphabetization, so, oh, and this also needs to be the vec. So we'll see if that's sorted. And in fact it did, so this actually does look right. I see, so here we have ties, and it happens to be sorted correctly. Hopefully one of these tests is going to cover the alphabetization breaking stuff. So let's just go ahead with let calculated. I don't know if we can use the same name. I'll just say calculated equals character counts vec dot collect. Oh wait, no. Yeah. Okay, wait. Dot map, and I don't know what to call this. So I'm just going to say CCV for character counts vec, or CC for character count, and it'll be, I want to map and have it return CC dot. Oh wait a sec. What? Hold on. Hold the phone. Wait, let me say that again. Okay, so 0 is the letter, and I got it. So 0 is the first element of the tuple, and 1 is the second element. So I sorted actually alphabetically and not by size. So actually, this should have been A dot 1 compared to B dot 1. Let's see what we get now. So now we get, okay, wait, that's sort of the other way. So I guess we want to do B compared to A, because we want the bigger numbers first. Nice, okay, so, nice, this is going to exercise the thing, because it goes X, Z, Y, and that's just not right. All right, that's fine, so we'll just keep going, and the test is going to catch that for us. So we want to map over these tuples, get the 0th value, which is the letter, and so now we might not be able to map over a vec. We might need to make it an iterator and then map it, but we'll see. The compiler will tell us. And then we want to collect it into a string. So to make that clear, we'll say like calculated, which is a string. Let's see if we actually need to. And I want to print out the calculated. And we can actually just return calculated now. And yep, map doesn't exist because it is not an iterator. So we can do that. We can say, I think we'll just say iter, call the iter function, and they'll make an iterator. And it couldn't collect it. Trace standard string. Collection of type cannot be built from iterator over elements of type char. Ooh, wait. So maybe this does mean I need to specify the type that I want it to build. No, same problem. Shoot. So we have an iterator of references to characters, and I thought you could collect a. I thought you could collect characters into a string. I thought that's just what strings are: is a collection of characters. But maybe the references to character thing is the problem. This is embarrassing because I have no idea what this is going to do. But I'm like, hey, what if we just use a star? What if the asterisk is the solution? Holy shit, it actually worked. So I think what that did was dereference it. So like it was a reference, and I want it to go back to being not a reference. Did that actually work? So our array of tuples look like this, and then our calculated checksum looks like this, which doesn't have ties broken by alphabetization. So that's where we need to improve our sort by. I'm not really sure what the CMP compare method. I'm not really sure how to like extend this, so I'm going to try to break this over multiple lines. And I probably need to read about what this CMP method does. I'm going to see if I can do GD. Shoot, didn't work. Darn. I was hoping it would jump to the thing. All right, so if we go back to the char docs, fn CMP, so implement order for char. This method returns an ordering between self and other. Read more. Haven't really dug into this yet. The method returns an ordering between self and other by convention. This returns the ordering matching the expression self, operator, other, true. Okay, so nice. All right, cool. So what we need to do is return an ordering of less, greater, or equal, and then that will dictate the sorting. So, I think that's what we want to do. I'm just gonna, like, I think we may want to implement our own thing here. So, like, so if we do b.1.compare a.1, and then, right, so the first one is less than the second one. So it's from the context of the first one. So b.1.compare a.1. So let's just do this. If b.1 is less than, or let's say equal, if a.1 equal b.1, we'll do one thing. Else, if a.1 is greater than b.1, we'll do another thing. Else, if, I would say else, we'll do another thing. And we'll return ordering equal. We'll return ordering greater, ordering lesser. Was that right? Oh, just less. So, oh shoot. Nice. Cargo test. So I should have the same behavior, I think, or I reversed it. Right. So this should have the same behavior. And I think it does. We have more output than before. Where did this come from? 5, 3, x, y, z, x, y, z. So I think that's fine. We just need to add some tie breaking here, right? So we never want to return equal. I think that's the idea. So we want to say if a dot 0 equal b dot 0, then we can actually return equal, and that's fine. Or, yeah, that's fine. If it's the same letter, then they're equal in every way. Else if a dot 1 is greater than, or sorry, a dot 0, and I guess this is a question, are there comparisons for characters? Or if we need to implement that, I'll be sad. Else, so ordering less, ordering greater. Here we go. So if a, b, z, y, x, we wanted x, y, z. So I guess I got these backwards. A, b, x, y, z. Does that look right? A, b, x, y, z. A, B, C, D, E, F, G, H, A, B. Okay, wait, one more thing. I think it's supposed to be the 5 most common, right? So we need to then do one more thing, which is to limit it to the first 5. So I guess I think there's going to be like a fn take method, right? So creates an iterator that yields its first n elements, so we can then say take 5 collect, see where that leaves us. And we have some passing tests now. Nice. Nice. Okay, wait. So our real test is passing, our new test is passing, and our example test continues to fail because it's still getting 4,000 and 1514. So this code is kind of gnarly. I'm going to get rid of our print statements because I think they are not necessary anymore. I feel like that this might be good. I'm going to get rid of that comment that I think isn't necessary anymore. Cool. So just to follow our failing test, we're still failing because this is 1514. Our sector ID sums method just hard code returns 4,000. So I think what we want to do is something like this. Self, let's start actually implementing this. Self dot rooms dot filter room dot real, right? Dot fold, and I think fold is the or how does fold work actually? I think fold is kind of like inject or reduce in Ruby. So let's see, fn fold. Expand an iterator adapter that applies a function producing a single final value. So we'll need it to be an iterator, and then we can fold. Yeah, I think this is good. Right, so fold 0 sum room sum plus, I guess this should be a reference to a room, sum plus room dot sector ID. Yeah, I think this might be right. So do we have? We don't have a test for this directly. Who cares about making that nicer? But we do. We are testing that here, which I guess there's an argument that this test really belongs in kiosk. And I think I'll just move it there. And we don't really need a test in main, actually, so far main isn't doing anything. So let's go back to kiosk, and so kiosk is kiosk new string from example. We're printing out the kiosk just to see if it looks right, I think. And there's a chance it's going to pass. No, it fails because vectors aren't filterable because we need to make it an iterator first. And we're trying to pull in the sector ID, but that attribute of rooms is private by default. Let's try that again. The real method, also private. Fair enough. Shoot. This kind of shit again. To print move, use ref room or ref mute room. Cool. This is a nice thing because the compiler wants to help me. I thought ampersand meant reference, but now they're saying just to ref room. I'm open to trying it. I'm glad the compiler can help. Woo! Okay. Hey. So our tests are passing. In source main, we're not referencing kiosk anymore. That's okay. So our tests are passing. So now what I want to do is what do you call it? So our program is still just a hello world, right? If we do cargo run, even though we've written all this code, we get hello world and we get all this warning output because we're not actually using any of the code we wrote. So let me get rid of that print line, and I'm going to copy these lines. And our main program is going to be pretty similar, where instead of asserting it, we're just going to print it out. We don't know what to assert because we don't know the answer. So we're going to say sum of real room sector IDs, and then we're going to say kiosk dot sector ID sums. And instead of reading an example txt, I'm going to read in input.txt, which doesn't exist. So oh, right, yeah. I was like, I thought I already pulled this in. I realized that's from when I started this originally. Okay, so we have our file. We have our main program, which reads the file and then prints the answer nearly at a moment of truth. Compiling, running, sum of real room sector IDs. It's kind of slow, wasn't it? Time target debug day 4. Yeah, this is my slowest one so far. I'm 2 seconds. Jesus. I think that my instinct is that the slow thing is that we're compiling the regex over and over, which I think is slow. So I want to optimize that. I'm not actually sure what's a good way to do it. Before I do that, I'm just going to test if this answer is actually correct. Submit. Okay. So we've done it. I'm going to try to optimize this real quick, just to confirm if that theory is right. In theory, I wonder, like, can I just move this here? That would be crazy, right? There's no way that works. Cargo test. Yeah, I can't do that kind of shit. So, like, the easy thing to do is to inject it, right? So, like, say, like, regex is a regex, and move it up a level, right? Like, if we room new, if we created the regex once and then passed it in, right? And then we would need to import the external crate here instead. I think this would work. Let's see. It totally doesn't work. Right. Yeah, so the problem is that it makes it a little harder to test because in here we're not passing the regex. Right? So I'm not sure a better way to do that. Like in theory what I would like to do, I guess I should search like Rust memoization. I spelled it wrong. Memoization Rust, memoized. So there's a thing. Keeping a variable alive across multiple function calls. That's interesting. Function memoize. Thread local. Oof. All right. Well. So I'm gonna not worry that tests are failing. I'm just gonna try to cargo run here, and Undefined or non-scope. Oh, yes. All right, well, I'm going to try to get it running just to see if that actually is the performance problem. And if it is, then maybe we'll figure out a better way to do it. Cannot find regex in room. Da, 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 da. So I guess I need that line as well. Value moved here in previous iteration loop. Oh, that's fine. Or wait, 23 is down here. So this is all fine. Potentially it'll work. Okay, cool. So time, yeah, much faster. So originally it took like 2 seconds to run. Now it takes much less to run. Not sure how to do this in a way that is like, ideally we would somehow be able to memorize it. I'm just gonna put it back how it was because even though it's slow, I think it's less awkward. So that goes there, and then this goes here. So cargo run should be back to our slow days. Cargo test. Okay, good. I'm going to commit at this point, and stop the video, I think. I'm not going to look at the part 2 for the video right now. I'm just going to call it done because I'm not sure how long I've been recording. Ah, right. I put a git hook to remind me to do cargo format. So the formatting stuff that cargo format just did, added a trailing comma, did that on one line, added a trailing comma, added a trailing comma. Okay, that's all fine. Da, 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 da. Ooh, no, don't add all those BK files. Hold on. Find dot name BK. Okay. The BK files are created by Cargo. All right, this all seems fine. And add day 4, part 1. All right, well, if you watch this, I really appreciate it. I sometimes make videos just to kind of help myself stay focused. Like, it's harder to take a break and look at Twitter or look at my phone when I'm trying to share something with someone. So that's helpful for me. And if you got anything out of it, I think that's terrific. And I appreciate your time and attention.